All right, we have made it through the session. We have a working IHSDM file. We have all the information coded together, and now all we have left to do is start running the evaluations and seeing kind of the safety costs of some of these roadways. Just to set the stage of what we do for this. So this is what we would call a no build model. So this is going to be your existing base condition of you're not making any changes, and this is the model that you're going to be comparing everything else to. You'll likely have 1 to 2 to 3 different build alternative models that have different geometry, different ramping configurations, additional lane capacity. There's a lot of different design considerations that can be a different design alternative. And essentially what you do is you compare the the build alternatives to this no build model, and then you can quantify the safety benefits through an economic analysis, or you can just compare flat crash numbers to see if your build model is going to reduce your crashes. And how it does that is there is a thing called a CMF, which is a crash modification factor, and there's crash modification factors associated with all sorts of these inputs, such as lighting, your lane widths, your shoulder widths, your median barrier, your outside barrier, your median width, your non-traversable median, every your horizontal alignments, vertical alignments, horizontal curvature. Pretty much every input in IHSDM has an associated CMF with it. So when you get those CMFs put together along with your traffic data, that's how you're going to get your predicted your predicted crashes. So we've done all the work that we can on the model of this no build. We have all of our traffic volumes. We have all the geometric coding done. So I'm going to just show you now how to run just a basic evaluation. I'm not going to get into an economic analysis or anything of that sort. I'm just going to show you how to run the basic evaluations. So you're going to want to close out of your viewer here. But now we just can go to new evaluation. The evaluation, you can title it whatever you want. So this is just evaluation 1. Typically, I like to leave this naming structure just so I know what it is or which evaluation it is that I've run. You can have multiple stacked up together just so you can reference them if you make changes to the models. But you're gonna select, so this is the full distance. If you want to, you can only look at specific parts of the alignment if you have multiple parts, or if you have an alignment that's longer than the limits that you want to evaluate, you can change these around. You're just going to acknowledge this. As far as configurations, we have a WIS.16.1. 16.1. Someone will be able to direct you on where to download that and how to get that installed. And then again, I mentioned in one of the earlier sections, for an empirical bay historical analysis, you can enter this data into your model. However, we don't have it for this just because it's a very basic tutorial. But if you wanted to, we'd have our site specific our site specific data, and you could enter your crash years, which you would have entered, and then that's how you would run an empirical bayes predictive analysis. The evaluation period is going to depend on your project, just depending on what years you want to evaluate. But in general, you should have these be years between when you entered your no build traffic data. So we entered from 2022 to 2045. A typical evaluation period is going to be 2025 to 2034, which is just a 10-year eval. That's pretty soon. Just starts in a couple of years. These dates will shift out probably 3 years plus whenever the current date is that you're watching this. But this is generally the date range as of now. It's going to say we have missing data, but it's just these sections that we didn't enter. So we just can click next through all these. It's going to pull open the report once we actually run it. So here is our first report. It's only 13 pages. It's a short one. Sometimes we get ones that are multiple hundreds of pages long. These graphs kind of show various like predictive traits of your roadway, degree of curvature, radius. You can see like the tangent sections. These are just all the parameters of your roadway. So here's an important graph just to look at is crashes by segment. So this kind of shows your crash rate by segment, and where it's going to be higher or lower based on the safety of your roadway. That data is not entirely interesting. So here's our kind of main table. So you can see your years. You can see, okay, so our segment length was almost exactly 1.5 miles, which is kind of crazy because I freehanded that alignment when I created it. But in that 10-year period, there's a total predicted crashes of 216-ish, with 70 fatal and injury crashes, which is kind of high. The percentage of those is 32 to 68, which is a little high, but again, it's a made up roadway. And then you can get your other key statistics is like crash rate, and things like that. So these are the numbers that are typically going to be pulled into a report where you can compare them directly to a build alternative and see your reduction in total crashes and then fatal and injury crashes. So that's kind of how you actually run the report. A lot of this information is not needed. The only other thing I want to point out is Table 8 has like an error message table. So if there's an issue with your coding, there's going to be an error message that pops up, and you'll know them when you see them. If there's ones that are problematic, I think they show up either orange or red. This one is just a warning based on an unbalanced type of freeway, which it's that last section where it's only a 2-lane and a 3-lane section. A 5-lane's not a supported type, so it analyzes it as a 4-lane and as a 6-lane and then balances the results, which is fine. It's just a warning, but this is where all your coding errors will come out, and then you can edit those accordingly to get rid of some of them and make your results a little better. So that's kind of what the reports look like. There's also this show CMF report, which shows the CMFs of your project. As I mentioned earlier in this video, there's a CMF associated with a lot of different things. So horizontal curvature, median width, inside shoulder width, high volume sections, outside shoulder. I don't have any user defined CMFs, but this is just kind of where you can see all the CMFs. A CMF above 1 is bad, a CMF lower than 1 is good. That's what that report is. Eric will sometimes have you look through those, or he'll check through those to find if there's anything egregious sticking out that is really skewing the results. Things that we've seen have been like really small horizontal curve radiuses, like less than 100 feet, will really skew the results, but they're easy to identify from that sheet. So that's kind of the last section that I had today. So you can also run an analysis for your crossroad, your 2 ramps, and you can also run them for your ramp terminals. And in general, when we report results, it's for the full corridor, meaning it would be for every alignment and ramp terminal in the study area. So you could, we have an automated way to import all these into a spreadsheet and then calculate out the total crashes of the whole corridor. That's a little too advanced for this tutorial, and you'll likely work with it as you start progressing through IHSDM. But that's a ways off, but just keep it in the back of your mind. So that is going to conclude the intro to IHSDM tutorial. Please reach out to myself or Eric or Sierra if you have questions, or would like to kind of learn a little bit more, I've got all these alignments saved as a kind of intro set where you can practice them yourselves. You can use these exact alignments. You can download open roads and create your own if you'd like, and practice that way. There's a lot of options for you to get some practice using the software. So that is all I have for this, and I will see you for the VISM sections in a few months.